आता मी दाखवला होगा तुझे. एक दोन मिनिट.
Star to continue. You will now be placed into the conference. Please press star to continue.
आर्टिकलचं सगळं
Hello?
manual वगैरे.
Hello,
Okay? What-
am I audible? Am I
Yes,
audible?
ma'am. Ma'am.
Hello? Yes.
Yes, ma'am.
Shall we start?
Yes, we can.
Okay. Is my screen visible?
Yes, ma'am.
Okay, I'm going to explain the hashing technique, that is chaining without replacement, once again on demand of one of the student. Uh, yes. Now suppose your numbers are 131, 3, 4, 21, 61, or else we take the another numbers. Let me take the example. Yes. Suppose my data is 12, 12, 1, 4, 3, 7, 8, 10, 2, 5, 14, 6, 28. Okay. Now suppose your size of your hash table is 12. Okay, and your function is key mod 10. So to find out the index and key, and this is suppose 10. Actually, we cannot consider this example. Just wait a minute. Yes, chaining with replacement. Take the data as 11, 33, 20, 88, 79, 98, then 44, 68, 66, and 22. Okay, and your function is again key mod 10. So let's add the numbers here. This is the key and this is the chain. Okay, here the index is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so first number is 11. So 11 mod 10 is equal to 1. So we need to store 11 at index 1. Okay, so here I am going to write 11. Got it, at index 1. Now 33 mod 10. Yes, we need to store the 33 value at index 3. Got this? After that 20. Now 20 mod 10 is equal to what? 0. So place 20 at index 0. After that 88. So you will get 8. So here at location 8 or index 8, you need to place 88. After that 79. So again you can place 79 at index 9, because after 79 mod 10 you will get the 9. Okay. Now next is 98. Now if you check the mod value of mod 10 value of 98, 98 mod 10 is equal to 8. But at position 8 we already put placed 88. Okay, and that is the correct position of 88 number, that is index 8. And here we are using chaining without replacement. So we are not going to replace anything, we have just need to find out the next empty position. So after 9, now 9 is the last position of your hash table. So after 9 again you need to move to 0. So 0 is already some value is placed at index 0, at 1 also, so empty index is 2. So we need to place 98 at 2. Okay, here I am going to place 98. Got this? Yes? After 98, yes, after 99, 98, next number is 44. We have 44 at index 4. After that, next index is 68. Okay. Now again 60 for 68, your index is 8. But that 8 index is not, or we already placed 88 at index 8. So we need to find out the next empty position, which is 5. So at location 5, I am going to place 68. Okay. Now at the same time, we have actually I forget to give the chain of 98. So at location 8, actually we need to place 98, but as that location is already full, we need to give the chain of 98. That is 2. Got this? Now after you place 68 at position 5, we need to write in front of index 2, that is 5. Got this? Got this? Is there any doubt? Yes?
No, ma'am.
No. Sure? If anyone has still doubt about the chain number, how we are going to place the index in the chain table or chain slot? Okay, so after 68, 66, 68, next number is 66. So mod value is 6. So you will get the index as 6. So place 66 at index 6. Okay, now next is 22. Now actual index of 22 is 2. Okay, but we already placed 98 at location 2. Isn't it? Yes?
Yes, ma'am.
But
Yes, ma'am.
we are applying chaining without replacement. If you want to apply chaining with replacement, in that case you need to replace this 98 by 22, because 22 is the number which has a actual index 2. Because index of 98 is 8 and index of 22 is 2. Actual index of 22 is 2, so we need to place 22 and index 2. But we are applying the technique without replacement, so you cannot replace that number. Okay, that's why again you need to search the next empty position. Now the next empty position is 22. Here at index 7. At index 7, I am going to place 22. Okay. Now what is the, now I need to write the index. Now actually originally I need to place 22 at location 2, but since it is not empty, the next empty position is 5. But again at 5 also we have placed 68. So next empty position is 7. So I am going to place 22 at locations or at index 7, and I have to write the value 7 in the chain table in front of 5. Got this? Yes? Got this? So all the remaining fields in the chain table or in the key table, you need to write -1. -1 means empty position. Got this? Got the concept chaining? Without replacement. This is without replacement. Okay? Let me check the chat box.
Yes, ma'am.
Yes, okay. Now let's see the example of chaining with replacement now. Okay. Suppose your numbers are 11, 33, 20, 88, 79, same numbers, 79, 98, 44, 68, 66 and 22, same numbers. Okay. Now this is key, this is chain, and your index is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay. So again 11, I'm not going to write the calculation here, just check the index. 11 index is 1, 33 index is 3, for 20 index is 0, for 88 index is 8, for 79 index is 9. Okay. Now your number is 98. Now for 98 you need to find out the next empty position, because we already placed 88 at index 8, and for 88 also 8 is the actual index. So though you are applying the technique chaining with replacement, you cannot replace 88 because 88 is correctly placed in the table at index 8. You cannot replace that one. You need to find out the next empty index for 98. Now next empty index is, yes, which one? Next empty index is
2.
2. Correct. So I am going to place 98 at position 2. Got this? And in front of 88 I am going to write 2. Got it? Yes?
Yes, ma'am.
Yes, ma'am.
Okay. Now the next number is 44. So place 44 at index 4. Then 68. Now for 68 again your index is 8. But 8 index is already full. So we need to find out the next empty position for 68, which is 5. Isn't it? Is this correct?
Yes, ma'am.
Yes. And where should I write the index number in the chain?
2.
In front of
2.
2, yes.
correct. So in front of 2 I am going to write 5. Okay. Okay. Now after 68 next number is 66. So 66 I am going to write here at location 66. Okay. Now my next number is 22. Now 22 mod 10 is equal to 2, but this index is not empty. We have already placed 98 at index 2. But for 98 number 2 is not a proper index. But for 22 2 is the proper index. We should have to place 22 at index 2. Now, if you apply chaining without replacement, then you no need to replace this 98 by 22 and search for the next empty position for number 98. Okay, but when you apply chaining with replacement, you need to place or you need to remove this 98 from this position, and you have to insert 22 here at position 2, and in that case you have to remove this index also, that is 5. So here I am going to remove 98 and I am going to place 22 at index 2. Okay, and now I am going to shift this 98 to the next empty location, that is 78. That is index 7, so here it is 98. Okay. Now what should I write in the chain slot of 7? Which index?
7.
7. Now when I replace, now my chain table is updated. How it is updated? Because you have already written at in front of index 8 the value 2, because we have placed 98 and index 2, but now your 98 it has position 7, so we need to remove this 2 and you need to place 7 here. Okay, now when you remove this 2 and 7, you have written 7 here, your next chain location or chain value of 68 is also will change, na? So in front of 7, that is index 7, when you put 98, your next number which has the mod value 8, that is which need to place at index 8, we have placed that number at location 5, so I have to write 5 in front of 7. That is the location for 68, and all the other fields write as -1. Okay, now now clear these two methods, chaining with replacement, chaining without replacement. Got it, everyone? Yes. Yes, hello. Is there still doubt about anything? In front of 68? No need to place anything in front of 68. Okay. So, shall we move to the next point?
Yes, ma'am.
Yes, sure. Everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Now the next concept is open addressing. Open addressing is also called as closed hashing. We already discussed this. Here, I think I have written here. Yes, open hashing and closed hashing. Open hashing means chaining method, And closed hashing means open addressing. It is also called as the open addressing, and in which we are going to study three techniques: linear probing, quadratic probing, and double hashing. Okay. So open addressing is a collision handling technique, and in which the entire hash table is search. We are going to search the entire hash table in such a systematic way to search the empty cell. Okay, and to insert any new atom when the collision occurs. So this is the closed hashing, or you can say open addressing. So let's see the first one, that is linear probing. Linear probing. So this is the simple construct which we already used in both the methods, chaining with replacement and chaining without replacement. That is what whenever the collision occurs and when the two records or two numbers demands for the same location in the hash table. That means when the collision actually occurs, then to solve this problem, you just have to place the second record linearly down wherever there is the empty location found. Okay, we have already used this technique in replacement, chaining with replacement and chaining without replacement. What this? Now for example, suppose your numbers are 131, 21, then 31, 4, 5, 61, 7 and 8. Okay, so again my index is here. Now here there is no chain slot, only the index and the data. So this is index and data. You just have to find out the next empty position to place the value if collision occurs. So for index 0, 1, 2, 3. Okay, so 131 obviously at index 1. Now for 21 also I need the index 1 itself, but index 1 is not empty, so that I am going to uh, place that 21 at the next empty position like 2. Now after that 31 also demands for the index 1, but as index 1 is not empty, just find out the next empty position. Now next empty position is 31, so 3. So place 31 at index 3. After that 4. So place 4 at index 4. Then 5 at index 5. Now 61 also demands for the index 1, but index 1 is not empty. Find out the next empty position, which is 6.
6.
So yes, so place 61 at index 6. After that 7. So 7 here and 8. So this is a simple linear probing technique. That is just one after another searching elements you can place. Got this? Yes.
Yes.
Okay. Now, when you study this linear probing technique, now in this linear probing technique, for example, suppose your numbers are, your data set is 19, 18, 39, 29 and 8. Okay, so when you place these values from in 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So I'm going to place this 19 at index 9, 18 at index 8. Now 39. Now 39 also demand for 9, but 9 is not empty, so that I'm going to place it in the next empty location, that is 0. So here 39 is there. 39. After that 29, next empty position 29. Next empty position for 8 is 2. Okay. So this block, that is index 0, 1 and 2, all these indexes contains the data which has actual index value, another actual index values, because actual index value of 39 is 9, 29 is also 9 and 8 is 8. Okay, but we are going to place this value at some other indexes, isn't it? Why? Because the indexes demanded by actual these numbers are not empty. So this is a major problem with this linear probing. This is called as the primary clustering. This is primary clustering, and this here, this is the cluster. This cluster is created here. Okay, so this primary clustering is a process actually in which a block of data, this block 0, 1 and 2, these three indexes forms a block of data, and in the hash table, when you resolve this collision, okay, so to minimize this, or you can say to solve this problem, we can use the quadratic probing. To solve this problem, we can use the quadratic probing, in which we are going to apply some other formula to find out the key value, or the hash table index. Key means hash table index. Okay. Quadratic probing. This is the second technique which we are going to use to solve the problems in linear probing. Okay, and what we are going to do in quadratic probing, we are going to use the formula to find out the index. Okay, till now is there any problem? Am I too fast today? Just give me.
मैम क्लस्टर वाला फिर से एक्सप्लेन करना.
Okay, just wait a minute. Yes. Now, what is cluster means? Now, suppose now this 0, 1 and 2, this all indexes are occupied by some other numbers. Now suppose after this 19, 18, 39, 29 and 8, suppose my next numbers are 10, 11, 12. Okay. Now here I cannot put this 10 at location 10 because it is already occupied by 39. So I need to place 10 at index 3. I need to place 11 at index 4. I need to place 12 at index 12. Okay. So this all three numbers are placed one by one and they are occupied by some others index, that is 0, 1 and 2. Therefore, this block is called as the cluster and we are called it as a primary clustering. This is a problem. This problem is known as the primary clustering, and to solve this problem we are going to use the quadratic probing. Clear now?
Yes, ma'am.
Okay. So quadratic probing. Now for quadratic probing, I am going to use the formula as HI key. Now here this formula is a generalized formula. That's why I have used I. Hash key plus I square mod n. Okay, now what is this M? Now actually this M can be the size of the table. Now suppose your table size is 10, that is from 0 to 9. You can take the value of this M as 10 or else any primary number. Please note this thing. M can be a table size or a primary number. Any primary number. Got this? Yes?
Yes, ma'am.
Okay. So only 10 minutes are remaining and I don't think so we can complete this problem in this lecture, and actually I have a one seminar to attend. So today I'm going to stop here. Actually Prabal has sent some link on the DSA group yesterday. Have you gone through that link, everyone?
Yes, ma'am.
Yes, ma'am, we have registered there.
Yes. How many of you have registered? It is not compulsory, but it's good if you are registered for the data structures course. You will get all the videos. Okay. You will get all the video lectures. You can solve the questions. And also if you give the examination of that, then you will get the certificate for the whole course. Okay. So I insist to everyone, yes, to register, yes, okay, Yogesh, Rathanesh. So if possible, if you are interested to do this, register for the course and please take some time to solve all the their assignments and submit all the assignments regularly. And if you get the above 60% in each and every assignment, you will get the certificate also. Okay. Actually, I have also registered for the same course as the faculty. Just a minute. Yes, one link is there in the chat box. Please fill your attendance and with code